At the beginning, you mentioned about its use for weight.
I've moved to a lifestyle block and I'm wondering something. I'm wondering if soil-borne pathogens and bacteria would be affected by use of EM.
Yes, because often it's soil-borne pathogens, and they're often a symptom of the soil not being happy. And so, what we found with EM is it tends to free the soil up, and we get more aeration. You know, like if you we definitely get an increase in earthworms when we apply it. We get a freer soil, and when you've got a freer soil, you've got more aeration, you've got better water movement, and that usually leads to less soil-borne problems, because if your soil's happy and more aerated, then those things tend to disappear.
Mike, I've got it's probably a little bit of a controversial question, actually, particularly to be bringing up at a soil and health meeting. But I was actually wondering, and I know you mentioned about plant growth regulators in EM. My question is, has there ever been any research or trials around the use of EM with herbicides, and specifically whether you could actually reduce the dose of the concentration of a given herbicide? I mean, I'm specifically thinking of glyphosate, which we do use at Botanic Gardens, and I mean, I have quite an issue with using that. But where I'm going with this is, I'm of the understanding that, you know, glyphosate basically works more effectively when plant growth response increases. Hence why I'm asking whether, you know, has there been any research on using EM with a lower concentration of herbicide just to reduce herbicide use, basically?
Yes, Lawrence. I don't like to sort of say that too much, but you know, sometimes when you have a product, you may not agree with the end use of or what they're trying to do with it, but if it restores, if it means they can reduce less chemical, then probably the end result is good, because less chemical going on, they're going to use the chemical anyway. But yes, we do have, particularly in the vineyard situation, we have quite a few vineyards that use EM in conjunction with Roundup, and what they claim is they're claiming a better kill and reduced chemical usage. You know, for a long time we would say no, don't put EM with chemicals, because it'll probably kill the EM. But that's one thing, and I have seen some work out of South America where they actually they showed they did a trial with EM combining it with glyphosate, and they looked at the effectiveness of it, and it did increase. So yes, you're right, Lawrence, it can be used to reduce. So, you know, I'd be happy for you to try that if you wanted to at a reduced rate and see what happens. I don't know what the mechanism is. You know, we've tried to work it out. The Japanese will tell you that it reduces the water clusters of the water, you know, in the solution, and therefore that then makes it more absorbable through the plant stomata. That's one thing. So, you know, is it also giving the plant a bit of a boost at the same time as it's getting the chemical? So, you know, it's more vulnerable. I'm not sure what the mechanism is, but yes, that is an application and it has been used. And there has been some evidence that suggests it works. So,
doesn't the glyphosate lock up manganese and things too?
yeah, it does. And you know, interestingly enough, some of the people that are using it are saying, well, we want to. We know that the chemical is killing microbes, so they sort of believe that by adding the EM in, they're kind of doing a bit of restoration at the same time. Now, I can't say whether it's doing that or not, but we did a few tests. I should say that I wasn't that comfortable doing it, but we did show that the EM survived being in glyphosate in a not a neat glyphosate mix, but in a solution with water. It survived. So there you go. I think the glyphosate does kill microbes, but doesn't kill all microbes.
Yeah, thank you, Mike. It's something. No, it's something I would be interested in. Yeah, giving a go at Botanic Gardens and certainly getting the team on board. Because I mean, we are trying to. I mean, we've stopped all our fungicides, insecticides. All of that was stopped years ago, and you know, I think anything to help us reduce that reliance on the herbicide is great. So
good, okay. Oh yeah, if you want to contact me directly, Lawrence, do so, and if you want to just compare notes or something, and
cool.
We'll send some up for a trial or something. Yeah, are you in the Auckland Botanical Garden? Are you?
Yeah, that's right. Yeah.
Okay.
Yeah.
Oh, good. Yeah. I know those. I think glyphosate's the one thing that the cities find very hard to wean themselves off, don't they?
It does. I mean, one thing I'd say about us at Botanic Gardens, generally, it's just the paths and the roads and you know all of those paved areas where weeds pop up. We've and middle of spring, summer, we're going around it 4 or 5 times in the season with Roundup, and it's that whole thing. I mean, public perception and not just public perception, but we do have the aspiration to try and get, well, at least reduce glyphosate. So
have they tried the steam
on
paving?
Yeah, we have. So we actually gave that a trial. It's effective. It'll kill the weeds straight away, but it's very, very expensive. The cost. I can't remember what the machine costs, but it's an expensive technology.
It's quite energy demanding too, isn't it?
That's exactly right. Yeah. I mean, there's a real. I mean, if you're doing the whole sustainability breakdown, your energy input is it's massive.
Just one thing more. We had a talk from Charles Highlander, and he's into biochar and stuff like that. And he was saying that that became a medium where the bacteria and fungi could reside, and that's how that sort of worked out. And he was also saying, by feeding it to cattle, it reduced emissions by quite a significant amount, and the animals actually put on more weight. So that would, in conjunction with biochar, all those things would work quite well, wouldn't it?
Yeah, we've often thought about biochar like in combination with EM, because the biochar is a great it's a great substrate for microbes to live in. It's got that all those that huge surface area, and microbes really do function well. It's interesting. The Japanese, when they were in the very early days making bokashi, and they made bokashi not only for the kitchen waste composting, but just for a fermented compost that they put onto their crops. They would often include biochar in the mix, in the combination, because it was so compatible with the microbes in the whole story that it was quite often there. They call it charcoal, but it's biochar. Yeah, but it's an area that I'd like to look at and see whether we can enhance the biochar if we put it in, or what it would do to the biochar. So it'd be a good little trial to see whether biochar on its own versus biochar with EM makes any difference. Makes an improvement. Just another little job I need to do one day.
Keep you busy.
They seem to be looking at the wrong end of commercial dairy farming, don't they? In the way that they were talking on Country Calendar about feeding them seaweed, the cows, because of the flatulence. But they're not really getting to the diverse pastures and things that are causing a lot of the, the lack of, causing a lot of the problems in the first place. Like all the ryegrass and clover all the time with all the bloating and everything.
Yes, imagine that. Imagine if we just ate 100% cabbage, how we would feel. Yeah, so that's the thing. Yeah, it's the diverse pastures would make a difference, I'm sure.
My question is that any specific crop or large scale planting situation where EM has been very much better received and more utilized?
There's not an industry that's that like the thing is, in New Zealand or in most of the developed countries, it's up to the individual farmer usually, or the there's not sort of one, there's not kind of a national system that I could compare that with, but no, I can't think of anything in particular. I've tested it on, personally, I've tested it on potatoes, I've tested it on grains, wheat, corn, fodder beet, kale, potatoes, in trials. I'm talking about, field trials, and in most cases we get a benefit. In most cases, I'm not saying every time we've had a significant result, but in most cases we have. But it's usually in conjunction. Most of those, it's usually in conjunction with something. It's not a fertilizer, EM. But it can have a fertilizing effect, because it'll work on organic matter, or it'll help release nutrients from the soil, and so therefore it does have a fertilizing effect. But it's not a fertilizer in itself. We're not applying nutrients, we're just making nutrients more available in a given situation.
I suppose my question was sort of went in line with what Lawrence said, because I remember a few years ago on one of the farm studies, and we visited a farm growing allium, onions and garlic and everything. And I was shocked at the amount of herbicides that had to be used just to keep the ground clear in places where they grow onion.
Yeah. Oh, absolutely. Yeah. Yeah. And that's a crop I've also done some research on, is onions. And yeah, onions, I did it on was an organic crop of onions. And the biggest cost for the farmer was the hand weeding of the onions, because onions, are not very, they don't compete very well. So you have to actually do a lot of hand weeding or spray chemicals. But a commercial crop of onions gets an enormous number of sprays between herbicides and fungicides and insecticides. So yeah, unfortunately, the average person would be horrified at the number of sprays that go on a lot of our crops that we eat, which is a real shame. But the average public does not know.
Mike, just to sort of following on from Ben's mention of alliums, I was wondering, do you know, would EM be effective against rusts? And I'm thinking specifically, garlic rust is quite a problem up in Auckland.
Mm. Yeah. Look, I've also found that it's not that effective against rust, to be honest.
Okay.
Especially, it'll reduce. It may delay the onset, and it may reduce the number of fungicides that have to be used, especially if it's used as in the preventative stage. But once the rust is on there, the EM will not get rid of it. From what I've seen, I haven't done a really serious trial on it though. I remember there was one organic grower that had a problem with tomatoes, and he had a disease in tomatoes, and the Japanese were always telling us 1 to 100, 1 to 200 parts on his tomatoes for this disease, and he got down to putting on at 1 to 10, 1 part EM to 10 thing, and he said it cleaned it up amazingly well. Now, that was far in excess of any recommendation that was ever made. Some people wouldn't do it, but then, maybe there is a point where you can get some control when you're using it at such a high sort of, but it must have just been enough to tip the balance, and it could have been a pH thing too. It might have just made it a bit more acidic, and then the disease decided it didn't like being in the presence of it. But no, so I just say, just experiment. It's got to be. There's always the danger with very sensitive plants that if you go too strong with it, you might burn them, because the pH of EM is around 3.5. So if you're putting it in at, if you're putting it in with water that's pH 6, then it's at a low rate, 1 to 100. Your pH is going to be nearer the 6 rather than. But if you put it in at, say, 1 to 10, the pH will be down. It might be down around 4. So anyway, I'm a great believer in just trying things and trying different ratios.
Just one other question along those lines. With the the use of EM to suppress disease, is that kind of, in normal circumstances, if you're doing 1 to 100, is the idea that the effect of microorganisms is sort of displacing or out competing the other?
Yeah, I think what they're doing. We have a few vineyards using EM, and I recommend 2%, so it's 1 to 50. And when you're targeting, when you've got a disease pressure, then you need to go a wee bit stronger. The 1 to 100 is kind of a general application that will, you know, just plant growth and everything else. So if you are coming under real disease pressure, then make it a bit stronger. I think there's two things that are happening. One is you're occupying the space on the leaf, and which then the other pathogen finds it hard to come in and establish. And the other thing, so there's that mechanism, occupying the space, and then the other mechanism is it may not like the chemistry of the EM chemistry or the, yeah, just, so it does have some repelling, it does have a repelling effect as well as I have seen a curative effect at times, but not on everything. So it can have some curative, but it's mainly like a preventer rather than a curative.
Well, thank you, Mike. I think that's a very nice talk you had, and very illuminating.
Thank you. It was good to be here, be with you all tonight. Yeah.